My name is Wilhelm Hocker. I manage the enterprise solution engineering team here at Parasoft. My career in the software industry began over 14 years ago. I've done a lot helping people implement continuous quality, continuous testing, helping them drive their agile transformation and modernization efforts, where none of it would be possible without the right testing strategy and test automation in place. So I'm happy that you chose this session out of all the great sessions that are going on today. So thank you for being here. And today we're going to be going over demystifying microservices testing. And before we get started, a little bit about Parasoft. We've been in the software testing space for over 35 years. We were founded by theoretical physicists from Caltech researching parallel processing, hence the name Parasoft. And over the years, we've been innovating end-to-end test automation for software quality and helping organizations with their testing challenges. So the first step in demystifying microservices testing is having a common understanding of what microservices are, what are the common messaging patterns that outline their behavior. And so the core principles behind microservices, they're lightweight, discrete services. They run as individually deployable processes using whatever technology that the teams feel is appropriate or optimal for their project. These microservices will often get grouped under business functions or domains whose composition of components represents the system under test. So we'll be talking about that composition of components more. And we see microservices come in kind of two flavors of message exchange. The first one being orchestration. So these are the APIs we're most familiar with, right? Synchronous request response, most often REST APIs. And then next, we have choreographed services. So these are services that use event-driven messaging where there's message queues in place to facilitate the communication between systems. And so in this talk, we're going to be going over testing approaches for both. So the next step in kind of our journey here is understanding how traditional methods of testing are not scalable when you have a microservice architecture. And so the most common form of automated testing I still see is that big, complex end-to-end test. And back when we were developing monolithic systems, right, where the data, business logic, presentation layer were all self-contained within the application, there wasn't much choice, right? We'd automate these system-level tests as best we could. And if we had good leadership, right, we'd make sure development was also maintaining a robust suite of unit tests as well. And for less complex systems, this worked okay, but now we have kind of a large headwind behind this legacy approach to testing. And so microservice architectures, they help organizations scale out their engineering effort, right? You can organize small teams working on individual components that collaborate together within the overall end-to-end system. And so this means that the systems that we're testing are getting more complex, they're getting more feature-rich, and the speed at which functionality is being delivered out the door is also much faster. So this growing complexity adds painful overhead when you adopt that end-to-end testing approach in your lower staging environments, because we have these large number of discrete systems. They need to be deployed. They need to have the right test data. And so it can be difficult to automate these end-to-end flows and just, in fact, set up the environment to do the testing where you can get feedback back to the development team to know whether they introduced a regression or not in a meaningful amount of time. Right. So if your testing cycles are in the order of weeks or months instead of days, then that's a hint that you've got a problem and you should look at your testing strategy more closely. And so this slower feedback cycle also has other negative side effects, right? With a longer testing cycle, you end up testing more changes. And so what was hard becomes even harder now because There are more features, more bug fixes that need to be validated in each cycle, and it becomes kind of unmanageable at scale. So with microservices, right, what development is doing here is decomposing that monolith into different layers or slices. And as a result, right, the deployment of that whole system gets a whole lot more complicated. But in this decomposition, we actually have a testing opportunity. Right, if you think about this monolithic system being broken apart, what we have is really a larger surface area for testing. And there's a big opportunity there. So it's not to say that end-to-end testing, it's not important. It's certainly important, but it's difficult to get automated testing done in sprint, done quickly, if all you're doing is end-to-end testing or UI testing. So we're going to take a look and see what can be done to isolate different components within the system from upstream and downstream dependencies, and how we can kind of take a fresh look at the testing process. So when I say upstream and downstream dependencies, what do I mean? So let's set some kind of common frame of reference for the rest of the talk here. So if you think about an API or a microservice as a black box, you can boil it down into the clients of the service and the dependencies of the service. And when you're testing your API as a black box, basically what that means is your test harness is acting as the client whose job is to verify that what it's receiving back from the service is correct. And then the dependencies to your service are what your service is working with as a client, in order to integrate with different data flows, et cetera, so that it can provide the functionality that it has. And so we're going to be looking at both sides of this equation here, both clients and dependencies. And so let's look at approaches to testing, right? Orchestration and choreography. So with orchestration, these are synchronous services. We have to consider both clients and dependencies here if we want to test our service in isolation. And so in this example of what the architecture would look like for, say, a brokerage, say a user wants to interact with their stock portfolio. And so the portfolio service, it keeps track of stock positions for the user. And so when using an API testing tool, right, the tool can add a position to the portfolio through the API's interface, and the portfolio service calls the account service to check if there's enough funds in the account, right? Then it checks the quote service to get the prices for the position that we want to add. And so there's some interactivity here that the service you're testing is doing before it sends back its response, saying, okay, great, a new position was added. And this is where your test will add assertions, right, to validate that the behavior of your service is correct. Now, at the same time, you need simplicity in your test environment, right? We talked about that complexity when we look at microservice architectures. So here, we want to use a service virtualization tool to basically simulate the dependencies to the service that we're exercising. And it allows us to kind of control our test environment, right? Where now we don't need that fully integrated environment anymore. We can say, okay, to get our in-sprint testing done quickly and easily, let's simulate the dependencies to the service that we're testing. And so in essence, we're sandwiching that service on both sides, and we have control on both sides. And as a result, that's going to make testing a whole lot easier to automate. Before I go, some other things I'll mention about service virtualization that's really relevant is testing rainy day scenarios, right? What happens if a dependency is slow or it sends back unexpected data? How does your service handle these negative scenarios? In the real world, right, these dependencies are built to work correctly. So simulating these error conditions, or what some people build as a chaos engineering practice, it's another great use case for service virtualization. So choreography, right here, we're trying to test an asynchronous service, and we have to consider the technologies that are being used here for publishing and subscribing to the event streams. I see Kafka, AMQP, WebSphere MQ, and even JMS as kind of the popular protocols out there amongst our customers. So here in this example, right, say we have the portfolio service, and right, our test has sent a message in to instruct it to add a position. And so rather than calling the account service directly, it publishes an event to a position added event stream, right? The accounts microservice is subscribed to that stream, so it picks up the message, sends back the results. Similarly for the quotes, right? There'd be another event stream for that. So you have kind of an order of events that's happening asynchronously. But ultimately, it's sort of the same idea, right? After the dependencies are invoked asynchronously, the portfolio service knows what it needs to do to add a position to the portfolio. And so from a testing perspective, we can push a message onto a queue. We can subscribe to different streams to see what events are flowing through the system, or what the end result is that we want to validate with assertions. And so it's important from a testing perspective that your framework has a wide variety of protocols that it supports, right? Not just HTTP, for example. So another challenge here to consider is the rate in which microservices are changing. And for complex enterprise systems, we see change as constant. And this is part of why testing microservice architectures can be difficult. There's many integration points between those services, and if one service changes its contract, right, and the schemas or message types, that can have cascading consequences on the clients of that service. And if you don't catch these sort of integration problems early, that can kind of slow down your whole release cycle, right? And you have to find these issues later and go address them when it's more inconvenient and expensive. And so one of the things that we can do here is looking at how we can reduce the stress on the tester, right? If all of these APIs are changing their contracts continuously, that puts a big maintenance burden right on the testing, because you're going to have test clients that are sending a specific message type. And so if those types are changing and evolving, you have to constantly keep up with that to make sure your automated tests are running and giving value in your CI/CD. And this is an area where the right tools that employ AI can help wrangle this maintenance of a lot of tests, right? You want your API testing framework to detect when these service definitions are changing, and then guide the user on mapping how that contract changed, right? Did a new field get added that wasn't there before? Or did certain fields get grouped differently into new objects in the response or request? And what is that mapping from the original to the new version? Ultimately, so that you can bulk refactor your tests, right? You develop the mapping, and then you save a lot of time in that maintenance effort, because now you don't have to go through your tests one by one. You can update them in one fell swoop. And so this can be a really big gain if you're looking at achieving that goal of in-sprint testing, getting feedback to development quickly. I mean, that's the goal of every tester, right? Is get it done quick so development has a lot of time to react. And this is one great way of doing that. So next, how does one really transition from this state of end-to-end testing to a more component testing mindset? We have this conversation all the time with our customers, and the enabling tech that helps you implement these testing approaches efficiently, where you discover what tests to create, and also what downstream dependencies you need to isolate from. Service virtualization has this feature that's called message proxies, right? And These message proxies allow you to kind of monitor and record the message flows between different APIs, as well as control the destinations of where messages are sent. Basically, how they work, once they're basically designed to listen on a given endpoint or queue, and then forward those messages that they receive to a destination endpoint. Basically, like a man in the middle for your APIs. You actively choose to inject them into your integrated systems, and once they're in place, you're ready to start taking advantage of them. So let's see what we can get from that. So there's two distinct angles, right, to component testing, right, the clients and the dependencies. So if we look at clients first, here the challenge is interesting because a microservice team, it's difficult for them to predict how other teams are going to be using their API, right? That's sort of one of the business blessings of having kind of like an API first culture, is that you have this API, other teams can use it to their needs, and you get this emerging complex system coming out of that. But knowing what those use cases are of your from your API is difficult. And so here, the message proxying capabilities found in service virtualization tools lets you record the traffic and then capture realistic usage scenarios that are going to improve your knowledge of, what are the clients to my service doing, and what kind of tests should I be running in my CI/CD pipeline without requiring those client applications to be the trigger, right, that tests my API. I really want to do my testing myself and not depend on, say, a cross-functional team. So, in other words, the recording enables you to replay these integration scenarios, and it's going to be a lot simpler and easier to manage than asking these other teams, right, to run their tests to make sure your API works. And so this is why tools that combine service virtualization with API testing are so popular. It's because they make it easy for you to kind of combine this recording to create your test clients using that traffic that you captured, and kind of bringing the process under your control. And so if we look on the other side here, the dependencies to the service, right? So from this vantage point, your service is the client, right? And testing your service can be problematic because now you have to rely on another team's APIs availability or test data, or sometimes even capacity to make sure that you can correctly test your microservice. And this can push the testing effort outside of the sprint, right? And makes it difficult for teams to detect these integration issues early enough where development can react to them. So what we're discussing here is really the kind of classical or traditional use case for service virtualization, where the technology allows you to simulate or mock what these responses of downstream APIs are, so you can fully test kind of earlier and easier within CI/CD. Okay. And so if we take a look at how that plays out, um, when message proxies are deployed in an environment, teams can record that API traffic and build virtual versions of the service that faithfully and realistically kind of reply to your service without having that real dependency in the picture anymore. And one thing that's important to note here is stateful transactions, or CRUD, like create, read, update, delete. These are important scenarios that your virtual service should be able to handle with ease, right? It's not just good enough to simulate static messages like, for GET requests. You want your virtual service to handle post, put, delete, so that it can really simulate or emulate the behavior of the dependency well enough that you can really test the integration flows of the API that you're trying to test. And you might not find all of that capability if you're looking at open source options. So if you're seeing service virtualization as a potentially good solution to help you with your testing problems in the microservices world, it would be good to consider that when you're looking at your requirements. So next up here, I want to zoom out the kind of testing scope a little further to that integration testing phase, right? So here we want to switch to real integrated environments, just to make sure that we haven't missed any defects, right? Testing in a production-like environment. And so you should expect that your message proxies here also give you control over whether you want to be component testing, where you're simulating downstream dependencies, or whether you want to be integration testing with real systems. And so one part of this is making sure that the service virtualization solution you have allows you to easily control these message proxies via API. We see organizations that have high maturity in CI/CD. They're running kind of deploy destroy workflows. They're looking to programmatically control the message proxy so that they can kind of facilitate what they need in the test environment for the different scenarios they have. And there's some optimizations that we can extract out of this visibility or observability that message proxies expose when you're kind of in this integration testing phase. And this is where kind of monitoring can be very handy. So if you're looking at service virtualization solutions, here's another requirement to look out for. Does the tool make it easy to subscribe or kind of get access to the data that's passing through the message proxies to integrate with the API testing framework? So a good solution is going to expose this monitoring topic, right, where the automated test can see the messages passing through these proxies that could be, various layers in the back end, so that you can see what's happening behind the scenes or behind the curtain to build a better test. So that's what we'll be kind of talking about here in our example. All right, imagine we have some order processing system and it needs to check various downstream services like inventory or billing or shipping in order to fulfill an order. So for a given test input, you can assert, what is the behind the scenes behavior to make sure that there aren't any problems there. So in essence, you're helping the developers pinpoint why a test is failing, not just that a problem occurred, right? So if we know where the problem is, the root cause analysis is much faster, remediation is much faster, and so you have a better test, right? You're kind of getting the best of both worlds in the sense, like you're still doing kind of higher level integration testing, but you're getting that level of visibility as if you were testing individual components in isolation, and making sure that end to end things are working properly. So if we look at the data or the traffic that we can extract from these message proxies, there's more we can do here, and this is where AI has emerged to help save testers time. So in this example here, we have a browser that's communicating with the front-end APIs of the application, which I often see are less documented and less tested than perhaps core APIs in the back end, right? Because teams may assume that, the UI is calling these APIs. So if we do UI testing, we'll test them well enough. But here, when you're testing through the UI and you're trying to do a better job and be more comprehensive with API testing, there's a challenge because you're not really thinking about how the APIs work or how they're used. The UI has all that business logic kind of abstracted away. And so it is orchestrating these sequences of API calls to fulfill the needs of, right, the UI workflow you're performing. But when testers need to write these API tests against the system directly, they don't know that business logic, right? They don't know what the UI was doing. So by capturing this network traffic while exercising the UI, an AI model can be built of which stateful data needs to be extracted and parameterized so that this sequence of API tests are going to faithfully execute that business logic defined by the user interface. So essentially, what I'm proposing here is a testing method for automatically generating API tests that perform the functions and workflows that you're typically testing through the UI, um, but doing it without the UI in the picture. And this has a lot of benefits if you think about how slow UI testing is, the high maintenance point associated with it. Right, diagnosing failures takes a long time. So adopting a lean UI testing practice where these business workflows end up getting tested at the API layer, it's going to ensure that your testing strategy will scale as the complexity of your system is growing. And while this example I shared here is kind of a UI calling front-end APIs, this workflow can really work even for API to API communication, right? Request response messages, great, we capture them, and then you can use AI to process that traffic to help you build tests. So next, functionality testing, right, isn't the only concern that keeps management up at night. We know that APIs have become the bedrock of how organizations are delivering functionality to their users quickly. But things like resilience, performance, security, these are all non-functional risks that continue to capture the public's attention, right? And many organizations are trying to reorganize their software delivery process to shift left the testing of these non-functional concerns to try to account for these important priorities. And this is where you're going to want a framework that not only helps you with functional testing, but also non-functional testing, kind of reusing the same, core architecture, core assets. So you don't have to necessarily conglomerate half a dozen tools and reinvent the wheel multiple times just because you need to cover functional testing, performance, security, etc. So what might a shift left API security testing workflow look like? And so, right, it starts with the tester creating API tests, ideally with the help of AI, right? So this is the functional testing that people get started with. But then the test harness should support, right, penetration testing using those functional artifacts so they can be reused. And so you can start exposing some security weaknesses early. And this is important because you want to kind of leverage that domain knowledge that development and test have of the application, how to exercise it, what's important, and giving them the tools that allows them to be productive for both functional testing and security testing, even if they're a security novice, right? That's really important. Generally, organizations will have a security team dedicated to this topic, but we want to give the ability for dev and test to run these types of attacks without having to know anything about security, so that when we get results and they're prioritized and risk is assessed, a security team can get involved from an oversight perspective or review perspective, or maybe, right, just review those early, get them addressed early, so that ultimately, right, the security team is happy because they're getting a more secure product and they're finding less issues late cycle. Development is happy for the same reason, right? Security is flagging less things that development has to fix at the last second right before release. So ultimately, this can be a practical workflow that dev and test can adopt that will help shift left security testing to kind of realize those goals behind DevSecOps. And the same workflow applies for shift left performance testing as well, right? Functional test artifacts should be able to be reused for performance validation with low effort. So teams that have a testing framework that supports this, they can reuse these test artifacts, add the performance validation into their pipelines. Results can be sent to a performance team, right, for review, or maybe dev and test kind of review and remediate early. But ultimately, right, both kind of workflows are the same when you think about it. And it's a nice way to get these later stage issues that performance teams and security teams are finding and bringing it into kind of the daily workflow or in sprint testing workflow to catch them and address them early where they're cheaper to fix. So closing out here, we have a couple white papers you might find helpful if you're evaluating API testing or service virtualization tools. I encourage you to scan the QR codes here, take a look at the links. We also can give you a personalized consultation if you'd like to go to the website and see how we can help. We've got lots of webinars, case studies, and blogs available as well. Tomorrow we're having our automated software quality or software testing and quality summit, where it's a half-day event. Companies featured from multiple industries will be sharing their continuous quality journeys. So you can find more information and register here in the QR code up top. So thank you very much for your time today. I hope you found this interesting and informative, and I hope you enjoy the rest of the conference. Thank you.